Dear students, let us learn how to balance a disproportionation reaction by ion electron method. See, if it is a normal reaction like one of the element is undergoing oxidation and reduction, it is easy for us to separate the reaction and balance them by ion electron method. But if it is a disproportionation reaction, so what are the steps to be followed? First of all, identify whether it's a disproportionation reaction or not. Simple. First, we find the oxidation number. The oxidation number of phosphorus will be 0. This is a medium, this is the medium, and phosphorus oxidation number will be minus 3. And here the central atom is phosphorus, its oxidation number is plus 1. Therefore, from the equation, it is very clear that it's an example for disproportionation reaction. So, if it is a disproportionation reaction, we have to separate them into oxidation and reduction. Oxidation reaction and reduction reaction. Reduction reaction. First step is oxidation will be P4 is getting converted into H2PO2 minus. This is the first step. First, try to balance the central atom. There are 4 phosphorus on the reactant side, only 1 phosphorus on the product side. Therefore, the first step is multiply by 4. When you multiply by 4, the interesting factor is if you consider the number of hydrogen and oxygen on the product side, both are equal. Since the medium is basic, instead of using water, we can just make use of OH minus ion and we can balance them easily. So if you add water again, second step you need to add OH minus. So instead of that, we can eliminate it. Therefore, to balance the other atoms, the second step is P4 plus I'll be adding 4 OH minus because 4 2s are 8 and 8. There are 8 oxygen and 8 hydrogen. 1:1 ratio that is possible with OH minus ion. Now giving raise to 4 H2PO2 minus. This is very important. After we balance the central atom and the other elements, let us balance the charge now. How to balance the charge? Simple. From phosphorus it is 0. From hydroxyl ion it is minus 8. Because each OH minus is minus 1 charge. So you have 8 such OH groups. Therefore, the total charge on the reactant side will be minus 8. On the product side, you have H2PO2 minus. So there is one negative charge on H2PO2 minus. Therefore, 4 such atoms are there. Therefore, it will be 4. Remember, whenever we balanced with hydrogen, oxygen and central atom, charge has to be balanced by adding electron. So where to add electron? That is also simple. If it is an oxidation reaction, how many charges are less? That many electrons should be added on the product side. If it is a reduction process, then add electron on the reactant side. Since there is minus 8 and minus 4, each electron is negatively charged, 4 electrons are less, therefore add 4 electrons on the product side. We get P4 plus 8 OH minus giving raise to 4H2PO2 minus plus 4 electrons. Now we have balanced the charges also. Now let us move on to the reduction process. What is the reduction process? Reduction is the same element is getting reduced, right? Therefore rewrite it. P4 is getting converted into PH3. What's the first step? Balance the central atom. Therefore it is 4. Now you balance the hydrogen. See, in the previous examples, we have studied that we used to start with oxygen because whatever so far we have studied, all of them had oxygen. But in this case, only hydrogen is there. So, when there is hydrogen, the rules are slightly different. There are 12 hydrogen on the product side. There are no hydrogen on the reactant side. If you are trying to balance hydrogen, what you have to do is, how many ever hydrogen atoms are less, that much H2O should be added on the lesser side. Opposite side, you need to add OH minus. Therefore, at the same step itself, both hydrogen and oxygen will get balance. Simple. When we write an equation, you'll understand. 4 3s are 12 hydrogen atoms are less. Therefore, I'll add P4 plus 12H2O, because that many hydrogen atoms are less, giving raised to 4pH3, same number of OH minus, that is 12 OH minus. Otherwise the equation will not get balanced, because when you add OH minus, again hydrogen and oxygens are coming up. So I have to get only 12, so I have just taken the double of it. So very simple. Now let's move on to the charges now. How to balance the charge? This is 0, this is also 0. On the reactant side, the charge will be 0. On the product side, pH3 is 0. There are 12 negative charges. Therefore, plus 12 into minus 1. Therefore, minus 12 negative charges are there on the product side. How to balance the charge? As I mentioned earlier, electrons should be used. How many electrons are generated now? You have to add 12 electrons. Where to add? Since it is reduction, add it on the reactant side. Therefore, the equation should be P4 plus 12H2O plus 12 electrons, giving raised to 4pH3 plus 12 OH minus. Let us call this as equation number 2. Now in any redox reaction, we have studied that the number of electrons lost and gained should be same. So how to identify? After we balance everything, just look at the number of electrons. Number of electrons during reduction is 12. Number of electrons during oxidation is 4. That's not at all possible. We have to somehow balance it. How to balance it? I'll get 12 by multiplying 3. Therefore, when you multiply by 3, you get a new equation, that is 3p4 plus 8 3s are 24 OH minus plus 4 3s are 12 H2PO2 minus plus 12 electrons. Call this as equation number 1. Compare equation 1 and 2. Now the electrons are getting cancelled because this is there on the reactant side. In the reduction, it is there on the product side. Now you add both the equation. What's the next step? Next step is add equation 1 and 2. Simple. Rewrite the equation. When you rewrite the equation, we get 3p4. Another p4 is there, that also I'll write it. P4 plus 24 OH minus plus 12 H2O plus 12 electrons, giving raised to 12 H2PO2 minus plus 12 electrons plus 4pH3 plus 12 OH minus. Now look at the equation and try to cancel the common factors. The common factor is 12 electron and 12 electron. That's the first thing. And look at the OH minus. There are 24 OH and 12 OH minus. So whenever there are common ions, bring it to the opposite side. So therefore, when you bring this 12 to the opposite side, you get it as 12 OH minus. Therefore, when you add 3p4 plus p4, it becomes 4p4 plus 12 OH minus plus 12 H2O, giving raised to 12 H2PO2 minus plus 4pH3. If you are left with electron, means you have made some mistake. So look at another important thing here. So here all of them are divisible by 4. So whenever we write the balanced chemical equation, it should be of simple whole number form. Therefore, I am going to divide the entire thing by 4. When I divide it by 4, we get P4 plus 3 OH minus plus 3 H2O, giving raised to 3 H2PO2 minus plus pH3. Therefore, the balanced chemical equation is this P4 plus this and this. So this is how the disproportionation reaction can be solved. Thank you.